So let's talk about the cloud. I think André already introduced me, but I live in Switzerland. It's kind of strange. You'll see that the company is vastly distributed. We try to have at least 1,000 miles between each cubicle, so that's a success for now. So you'll have excuse my accent. There is not much I can improve. I've tried. I used to be at JBoss. It was a great adventure. I started as a developer there and started building the business and helped with some of the acquisition we did there. Then joined Red Hat in 2006 and was part of the middleware division. So I see some Red Hat T-shirts in the room. That was my family for a long time. And recently I created, well, it was 2 years ago. It sounds like yesterday, but it was already 2 years ago. And we're about 30 persons now in 6 countries. We're trying to increase the number of countries we're covering, but 6 is not bad. In the US, one of those countries is the US, and we're in 6 states as well. So we really try to maximize the spread. So I wanted to start this presentation by a story backwards. So I want to make an analogy with some other things before talking about the cloud. I think it's very important. Then I'll speak more specifically about the cloud, what it means to developers, and then I'll do some weather forecast, and after that we'll jump for a demo. Before we jump into it, I'd like to ask a few questions to the audience. So who is a Java developer first? Okay, so it's the kind of question where it's easier to say, who is not a Java developer? Okay, a handful. Who has already deployed something, anything at a cloud provider? Could be Rackspace, Amazon, or anybody. Anybody deployed at Amazon, for example, specifically? So has anybody used the platform as a service? Okay, somebody at the back. Here. So it's always difficult to speak about the cloud because you have one part of the audience that knows everything about the cloud, and you have other part of the audience that don't know much about the cloud, wants to learn. So if it's too high level or too low level, just let me know. I'm sure I can adapt. But the idea is really for this session to go through all layers of the cloud and understand what they mean and what they mean to developers. So first, I wanted to discuss about our ability to predict things. Typically, we're pretty good at predicting what's predictable. That's at least my experience. So when there is no disruption, when there is a constant speed, let's say you have this graph here, and somebody would ask you, what do you think we're going to do next month? I'm pretty sure you would not say it's A or C. You would say it's B. All things being equal, it seems like pretty good. So, we know on average how things should happen when nothing bad happens. But when there is something called a paradigm shift, it's much harder to predict how things will evolve. So for me, one of the best examples is a phone. If you have kids, maybe one day they ask you, why did you have cord to your phones back then? What was the need for that? What was the feature? There must be a feature associated to that. And for example, when you were in a train, how would you call somebody? Because this cord was probably not very helpful, right? And so it was hard. It's very hard in those times to think about what it could mean when you don't just do a longer cord or a smaller phone, but you totally disrupt it by having no cord and the ability to move everywhere and give calls from mountains and so on. It's a total disruption, and that's pretty hard to figure out. First, it's hard to guess what those disruptions could be. If we could guess what those are, I'm sure we could make a lot of money very easily, right? And even when they seem to happen, it's hard to predict what could be the next dots on the line. What does it mean for developers? What does it mean for IT? It's a kind of things that are hard to predict. The same is true. I've seen many people speak about coaches versus diligence as well. what would be the next version of the diligent, faster horses maybe, or blue horses? What could be the next big thing? Well, it happened to be trains instead of horses. So I think the cloud is part of that type of paradigm shift, and let's see why through something entirely different. So there is something you I hope, know pretty well. It's electricity, right? So that started at the end of the 19th century, some nice inventions there. And what you see here is a power generator. And they were complex, fragile, very costly. You had a few rich people and rich companies we had a lot of visions that decided to have such equipment to improve their efficiency, but it was extremely rare. And very quickly, people saw the light. That's an easy one. But they really saw how they could leverage this. But they also understood how it was not. They could not expect everybody to create their own power generator and simply expect that this would work. They knew that they had to commoditize this by having either companies or a government take on the role of building those sophisticated piece of technology and then reselling this electricity. So a big boost was the Universal Exposition in Paris in 1878. And following that date where they spoke a lot about, they were exhibiting those power generators, you had a lot of cities that decided to push some of those power generators. So that's at the end of the 19th century. And you had some nice buildings, so sometimes you had to be close to the water, right? It helps if you want to create electricity. Sometimes you had some very nice buildings. You have to understand this was high tech, right? That's really high tech back in the days. That would be the Googleplex of the 19th century, for example. But it wasn't as simple as it seems. It looks like a nice story and so on. But between that and what you can see in your walls, which is well-identified plugs, a few years passed. And so back in the days, there was no standards. Is it AC, DC, what frequency, what voltage, and so on. It was all over the place. So for example, again, I don't have anything specific to Paris, but I found lots of information about Paris. So this map is interesting. That's the center of Paris. And each color you can see, so that's the river, the Seine, and each color is a different region in Paris. And so you could see here, it's an AC single-phase zone. So if you wanted current, it was single-phase AC. This one is double-phase AC as well. This one is a 5 chords zone, whatever that means. This one has just three chords. So it was really all over the place. And that's only for a city, right? So let's not even speak about freedom of the consumer to go from one place to the other, right? There was no way you could move your infrastructure from one place to the other. And today, we have standards all over the place. So we went through a great progression, and now you have the notion of grids. Inside grids, you have different type of producer. It could be hydraulic, nuclear, solar, coal, whatever. Then you have the notion of distributor, which is local to where you are. Then you have the notion of a plug. You know always what to expect in a plug. You can go to your neighbor's house. It's always the same voltage, same current. It's great. It works. So it took us maybe a century or maybe 50 years to get there. But we've really been able to commoditize this technology fully. So let's see what is the state of IT today. So sometimes I feel like IT is very much like electricity at the end of the 19th century, right? I'm not sure I don't think you're gonna be surprised by this kind of server setup. Who that strange company could be? Oh, that was the first data center for Google. That's how they started. So could we try to see an analogy between what happened in electricity and what could happen in IT? Obviously, it's not the same thing. You could see a lot of differences, but still, there is something that can be said about IT and electricity. So sometimes it can be pretty rudimentary. Everybody will say, that's not the way it works, right? But I've seen that many times. Sometimes it's chaos, right? I suspect there is some computers behind this. And sometimes it's more interesting. At least this one has kind of an artistic style. It looks very sophisticated. This one is more fuzzy. So I think today we're kind of treating IT as haute couture. You know, haute couture is those sophisticated clothes you can buy at Chanel or whatever. You know, it's always custom, it's unique, it's very costly. There is a high overhead. And I think that's very much how electricity was back in the days, either in Paris with a multi-zone or those complex, sophisticated generators. And the cloud is really trying to bring us there, So it's pushing us through an extreme standardization of what you're consuming. So we're transforming IT not just as some kind of super custom piece of technology, but really something extremely standardized with a huge economy of scale. So we can thank Jeff for that, Jeff Bezos, the CEO of Amazon. Obviously, the idea of the cloud is not new. I'm sure you could find books long ago speaking about the idea of clouds. But to make it happen, you needed a critical mass. And the persons with this courage, this critical mass, and so on, have been Amazon. Amazon had a problem, which is they needed to have capacity to handle all of the peaks. You know that if you lose X hundred milliseconds per call, you know that the number of customers will drop on your website, a few percent points. So you want to make sure that you can always serve your customers. But since those guys were selling, for example, at Christmas, a lot of things, they needed to have maximum capacity at all time. That was not very efficient. So they said, well, why don't we try to rent it? So they've put some API, and they said, OK, guys, you can rent our capacity when we don't need it. And it worked. Just look at this graph. This graph here in blue, that starts in 2001. That's the bandwidth that's consumed by Amazon for their website, right? So nice growth. In red, that's the bandwidth consumed by Amazon for Amazon Web Services. So that's us, right? When we go on Amazon and rent some machines. And that, so you can see the crossover point here is around 2007. So that was 5 years ago. I'm not even sure the graph would be interesting now, right? You'd have like a blue flat line and a red horizontal line. But that's a success that Amazon faced with Amazon Web Services. So it really served as a catalyzer for the cloud. So some additional pictures. Personally, I love this one here just because there is a guy with a bike. It never happened to me to be with a bike among my servers. So I think that the cloud will do to IT what electricity has done to the industry and the industrialization, which is a huge boost, huge economy of scales. So let's try to see how we can benefit from that. So to finish my analogy with power plants, electrical grids, and electrical plugs, the analogy is really this one, right? You have power plants. They are the anonymous generators of the small electrons you receive in your plugs. Well, those are the cloud providers. You don't necessarily need to know where they come from. Well, in some cases you do, right, for legal reasons or for latency reasons. But other than that, it's less interesting than it used to be. Electrical grids, how you spread that processing, that information, that's internet. And the electrical plug is really how do you consume this. And that's obviously the browser. And HTML5 has done great progress there. So we can see a great analogy about the consumer, the distribution, and how we produce content. So that's great. But what does it mean to me as a developer? So we've seen that. Well, I told you, and I hope you believe me, that the cloud is going to be huge. But what does it mean to us as developers? How do we take that raw energy, this set of feature, and make it something useful for us as developers? So let's go through a Cloud 101. Typically, what we see in IT is this. So we call it a software stack. So you have a server, maybe an hypervisor. It depends if it's a guest or the host. It might be the other way around. A virtual machine, a Java virtual machine, an app server, a load balancer, some application. We might have databases and so on. And so we are kind of used to that way of working, right? We have IT teams in some companies setting up those stacks, or standardizing those stacks, monitoring that everything is going fine, updating those stacks when you have patches to apply. We validate them. So we kind of understand how it works in the traditional hosting environment. Now, when we move in the cloud, we still have very much in mind, that strongly in our DNA, we still think about stacks and software stacks and how do I get my VM, how do I get my JVM. That's really how we work. But how does it work in the cloud? How do we build those stacks? How do we maintain those stacks? We kind of lose our common understanding of what we can do there. Kind of resets things a bit. So the answer is easy. Just use a XaaS, right? It could be a SaaS, a PaaS, a IaaS, and just use it. That's great. Okay, a what? What does it mean? Can I use a IaaS? Should I use a PaaS, a SaaS? What's the difference for my own need? So that's what we're gonna try to see in that next section. Yes. So as I said before, AWS is the most popular example. And the best way to understand IaaS is the Lego blocks, right? Those are really the basic blocks of IT. You want some compute, you want some storage, you want an IP address. That's really the basic blocks of IT that are provided by Amazon. So typically, if you were to work with a IaaS, you would say, give me a server. I want to install this image. So it's like a virtual machine image on this server. Then I'm going to set up some software on top, like an application server. I'm going to define some rules for my firewall, a database, and so on and so on. So it's extremely flexible because it's a machine. So you just need to put whatever you want on top of this. But on the other hand, it's pretty complicated, right? Each time you have a lot of flexibility, it comes with its own set of issues. From a user point of view, it's typically a good thing if you want to build custom systems. So it's not so much about applications per se, in terms of developers. It's more about systems. Let's say you are running an existing server in-house. It has a specific version of MySQL or Microsoft SQL Server. You need a driver. You need some sophisticated stuff, whatever. You can build that with a IaaS, right? Because it's just a bare-bone machine that you can customize all the way you want. So AAS means as a service, right? So that's really the first. It's important in the cloud. We want to consume things not as software, not as bits. It's a service that we receive, typically through an API. And then you can receive either infrastructure as a service, right? Either a platform as a service or a software as a service, okay? So we typically represent those in those layers, right? Because you typically have the infrastructure, which we intuitively understand as servers, operating system, and so on. Platform would be more like middleware in the cloud, and software as a service would be ready to be used software that, Salesforce.com is an easy way to describe SaaS. Okay? So it's not so much about applications, it's more about systems when you want to create something from scratch. So for a developer, you might think initially, well, that's pretty good actually, because it doesn't change too much what I'm doing today. Back in the days, I was using some HP box, IBM box, Sun box, next to me. And now I'm just going to use an AWS box. What does it change, right? It's a server, so it's all the same. Well, actually, congratulations. You actually became the new guy responsible for the data center, right? Back in the days, you would need to carry those big boxes, install them, wire them, and so on. Okay, you don't do that, great. But yes, you actually do it. It's not carrying big boxes, but you're going to do it through API, through command line purchase instance, migrate image, make a snapshot, get an IP address. So everything that you would typically do by walking around and doing things, you don't do those things. You simply ask that the robot does it. Well, obviously, it's all virtual, but that's what happens. And so sometimes, if you're lucky and if you have smart guys in your IT, you'll start hearing things like Chef or Puppet. Those are tools that help you automate those steps, and so that you don't have to go through each of those steps. But it's pretty complex, right? You need to start from scratch. Can you imagine in your mind for a second all of the steps you need to go through to go from a machine that does nothing with no operating system to a machine that does, that serves a website? It has many, many, many things. Just the storage, the backup, and the failover, and how do you recovery, and so on. All of that needs to be completely automated as part of your solution. So I have a colleague that loves playing Lego. So he took some picture on what he thinks is a YAS. So that's great. I can do whatever I want with those Lego. That's very much a YAS, right? You can end up with funny things, but it's possible. You can do it. So the consequences of using a YAS is that you're directly managing your resources. So you have really complete control over those resources, and it's CapEx free, meaning you don't need to pre-buy those machines. So one of the advantages of the cloud is that you can rent resources by the minute or by the hour, whatever, right? It's an on-demand model. You might want to say to Amazon, please give me 100 servers for 1 day. I'll do some compute, and then I'll release those resources, and I don't have to pay anymore for those. So that's great, right? For many applications, this is exactly what you want. When it's a spiky usage, that's what you get from AWS. But actually, the kind of what I call soft IT, right, because you're not walking around with boxes, required to make it happen, I suspect is higher, at least in our experience. If you want to do it right, it's going to be very hard to do. You still need to do all of the traditional IT activities like patches, backups, and so on. But then you need to also do some stuff that are specific to the cloud. Like how do you do elasticity, security, automation? All of those are kind of done differently in a cloud environment. And what's great about the cloud is that it's very agile. You can create and kill machines. But sometimes, it's also very agile on the other side, right? Server might die. Okay. So what do? Well, you restart the machine. Oh, I need to go through all of my steps? No, that's why you need to automate it all, right? Because you want that if something breaks, you can restart it in a snap, and it needs to be fully automated. And very few companies actually might be doing that kind of things internally. So my advice, if you're a developer, you might want to move on. At the other extreme, so if it's not YAS, look at SaaS. The best example is Salesforce.com. That's when you just need to use the name of a company to define a layer. That's always very good. So in that case, a big added value of a SaaS is that if you need a standard application, so it's not something too fuzzy, right? Like HR, CRM, ERP. So the needs that are well defined, you typically find a SaaS solution that will fill in that role. And what that means is that as a customer, you won't need to install that software, spend a lot of money configuring that software, then worrying about when and what to apply in terms of patch, what it means when you add more users, it needs to scale, so you need to add more machines. So all of those tasks, IT tasks, are integrated as part of a SaaS offering. And you don't need to do anything. You simply go on the website, you say, okay, I'm going to register 1 user or 1,000 users, whatever, and the provider is going to provide that software, that functionality, but as a service, and you don't have to do any of the IT operations related to that setup. You don't need to set up servers. You don't need to worry about air conditioning or whatever. You just consume it as a service. So it's very fast to bootstrap from a SaaS. It's great, if you have a need that is satisfied, in no time you can be up and running. It tends to be relatively rigid in terms of configuration. Again, it depends. There is no unique rule here. But Salesforce will be pretty flexible in what you can do, but some others might be less flexible. Typically, it's going to be customization through configuration, right? You have some configuration settings, you can adapt it to your behavior. Sometimes it's fine, sometimes it's not fine. You know, that's a price you pay. And most of the time, the lock-in can be pretty high because they're going to use their own data structures, their own processes, and so on. So if you want to move away, say, from Salesforce.com, it's possible, but it's not an easy endeavor, right? Because you need to, you'll get raw data, and you need to re-import it in another system. It tends to be pretty hard to achieve. So again, my friend showed this image to describe a SaaS. So it's great. It's all well contained. You know, there is nothing wrong. It's all round and cozy. But if you want to make some extensions, it's pretty limited, right? You can't really plug things. It's a pretty monolithic piece of technology. So let's go to PaaS now. So what is a PaaS? A platform as a service. So even so, you can find lots of different philosophies. The idea of a PaaS is to say, I don't want to talk to the IT guys, like the infrastructure layer, or I don't want to speak to the end user, like a SaaS. I want to speak to the developers. So my audience are the developers. And what do you care about as a developer? Well, you typically care about applications, databases. You care about testing. So those concepts are going to be the concepts that are introduced by the platform as a service. So each time you need to do custom development, but you don't want to handle the notion of servers and so on, then a PaaS will be the right layer for you. So you can really see that as an intermediary layer between SaaS and IaaS, where you don't need to worry about, do I need a firewall, do I need storage, how do I do backups, and so on. You know, that's pretty low level. At the same time, you will not find a software that makes what you need, so you need to do some custom work without having to worry about the lower level details. So again, that could be what a PaaS is about. So you would have, for example, typically a IaaS provider in blue. So that's the infrastructure, the servers, the storage. Then in green, you would have the platform as a service. So it leverages those servers. Obviously, we're not running out of hot air, right? We still need servers and storage, real stuff. And we're going to expose a very different API on top, which speaks to developers. It's going to be about applications again, about storage, about elasticity, how you want to scale, and so on. And your application is going to be this red box on top, which defines what you want to run. And then it's going to handle things like load balancing, for example. So you receive requests, and you want to dispatch it to the right server. Maybe you have multiple servers, so maybe you need to have sticky sessions and so on. Maybe you need to replicate the sessions to have failover. Maybe you need to have the application scale automatically. For example, let's say you have more users. You could tell your PaaS, well, you know what? When the response time of my application goes above 150 milliseconds, add more servers. And then try to reduce it. You know, that's the kind of things you could say. You're not going to say that kind of things if you're working at the infrastructure layer, right? You would need to say, I want a server. And what is the notion of request for an infrastructure layer, right? It's a server, it's an IP address, it's a firewall. You would need to install a load balancer. You need to install a monitoring logic on top. You would need to receive indication of what the average response time of that application, put some logic to detect, oh, it's above some ceiling. Then if it's above some level, you would need to provision a new machine, reset the firewall, make sure that the load balancer can talk to that firewall, then change the configurations of the load balancer. You know, that's a lot of fine-grained technical details at the infrastructure layer. But as a developer, you don't care. You just want to say, I want my application to scale. And to me, scaling means response time in that range. Or I want to handle I don't know, 200 concurrent requests per server. That's it. I don't want to know how you do it, what it means, just do it. So that's the level at which a PaaS will typically work. So again, the center of the world for a PaaS is going to be application, data, tests. That's going to be the level at which it's going to work. And then we apply the concept of the cloud. So the concept of the cloud are, it needs to be on demand. When I need it, I want it. You know, I don't want to go and sign a contract. I want it, I get it. It's pay as you go. It's So if you consume 1, you pay for 1. If you consume for 5, you consume for 5. And so it's really based on your usage. Okay? So what you get from Amazon, from a resource standpoint, you also get it from a pass at the application level. Okay? If you want one application with some memory and just one server, you're going to pay some. If you want more, you're going to pay more. But it's really on demand. And one important point, I might be speaking too much about this, but this is a service. Keep that in mind. This is a service. It's not software, right? What's interesting is that you don't have to worry about it. You don't know how it works. And you know what? Maybe it's going to change tomorrow how it works. Maybe the load balancer technology will evolve, and we're going to have a cool, neat product. Well, not your problem, right? It's our problem as PaaS providers to make sure that you have the best of breed technology underneath, right? So it comes as a service. You have a set of API, a set of features. That's what you get, but you don't care how it's being operated behind. So the first decision as a developer is going to be IaaS, PaaS, SaaS. So with a IaaS, you're going to juggle with all possible technologies, very flexible but extremely complex. A SaaS, very fast to get something up and running, but very constraining. There is not much you can do to customize it. And a PaaS, which is in between. It is flexible and adapted to what developers would want to do. You can see where I'm going, right? Any question at this point? Yep. So the question is, well, PaaS is great, fine, but how do I control what's under the hood? Because sometimes I need to. So there is kind of a philosophical answer here, 2 parts, right? The first one, which I'm not sure if it's your case, but some people tend to, when they see PaaS for the first time, they're very much into a mode where they like to control. They've been controlling things forever, right? And it's a bit the same thing as 20 years ago when there were super high-level languages like C, And like, yeah, but I can't do a shift left, or how do I do that, right? And so first step is really for those developers to understand, don't focus on that. Just focus on what you need to solve. And we tend to forget as developers that we're not just geeks. We try to solve a business problem. And the business problem is, either you need to make it cheaper, faster, better, right? That's the kind of requirements we receive from business, right? And should we worry about the driver and the version of the JVM? So the first notion, I think, to absorb is don't bother. Refocus on your business. Stop focusing about IT and servers, right? And actually, if we could have a single server on Earth that would run all of the workload on Earth, I would love it, right? And we can't do that. We haven't invented that. So we have to handle lots of small servers that keep crashing left and right. So that's a problem. But we have to force ourselves as software engineers to stop focusing about that. Now, that was for the philosophical part. Then there is a reality. In some cases, you're right. It just doesn't work.
It just doesn't work.
Right? Because maybe, I need a special driver that's going to handle, some hardware that will do some sophisticated stuff. Okay, that won't work. Sometimes you have some super sensitive software. Not going to work. But I don't know, 2 years from now, 5 years from now, 10 years from now, it's a paradigm shift, so I don't care. It's like Paris 1902, right? I don't care if it's 1907 or 10 or 15, whatever. At some point, software will be implemented in a way where those type of requirements are not part of the software. Where developers say, okay, I care about a PaaS, that's my destination, so I tend to relax that kind of constraint. And yes, my bet is that by 2020, 80% of the workload will work in public cloud and on PaaS or SaaS. But 20% will not do it because they are super sensitive things, maybe just because you can't, and so on. But by and large, if I don't try to focus on exceptions, I think a wide majority of the software can run in such an in such a context. Yeah, so a good question as well, which is, why can't we have PaaS a la carte, essentially, right? Instead of having a monolithic PaaS or whatever, and you do it all, why can't I have choice on what I put? I think some PaaS works this way. So some PaaS out there, I said, initially you have lots of different philosophies. So some PaaS work exactly this way. On some paths, you can see your load balancer, you can see your servers, you can see the configuration of your load balancer, of your HTTPD server. You can see all of that, and you can modify and fine-tune it. So I'm going to preach you my philosophy, right? I think it's bad. I think it's bad because that's exactly what I don't want you to see, right? Maybe you will feel unconfident initially because you'll feel like, yeah, but you know what? I'd like to do what my ModJK thing is. Forget about it, right? And so that's why I think it's going to take time to get there and for developers to get used to that kind of philosophy. But I see huge value in that. And you're right. There will be a time during which maybe it will make more sense to have those custom environments. I think what we're going to see more and more, and I think .NET had this notion of safe versus unsafe environments. So I think we're going to go to a place where PaaS will provide safe or fully managed environments that will be kind of monolithic, right? Where we handle everything, don't bother, and so on. And if you have some edge case where you want to do things on your own, they still provide a lot of the infrastructure they have in terms of deployments, monitoring, provisioning, all of that billing and so on, but with the ability for you to provide what you want to run in those containers. And it's unsafe or unmanaged just because then if there is a bug or if there is a security issue in that code, what do I know? It's your code. We're going to fix our bugs, but we're not going to be able to know what's running in your server. So I think we're going to see this dichotomy. So if you haven't heard the notion, it's really, okay, you're going to do some modification under the hood. I'm okay to relieve control. But what tells me is that you're actually not changing the contract implicitly, even slightly, which will make my application misbehave. You provide some kind of certification, like we have J2E certification, to make sure that at least the foundations are safe. So I think we're still in the infancy of what we could do there. It's still very early. Nobody is doing that kind of certification. What we do see is more in terms of the release process. And so if you take a Salesforce, for example, where you can host code as well, what they tend to do is tell you all of the minor updates, security patches and things like that, we're going to do it under the hood because it should not impact you. Yet when we do more sophisticated releases where we might change the semantic or we add new objects or new types to the platform, we're going to give you a conversion window. So we're going to run the new one, the old one in parallel for, say, 3 months. It's up to you to test it to make sure that the contract is still good, and then you do the switch. I actually like this idea. I think that the automated testing is something that providers have to do to make sure that it's stable, but it's not sufficient, and at some point you need to give that type of control to the developer and tell him, you have the switch, It's a per app switch that you can do. We could do it automatically, but if it breaks, it might happen. It remains software. Think about it. It's exactly the same thing that what happened with operating system vendors and ISV. Right? Take a Red Hat. I don't know how many they have, 3,000, 4,000 ISV certified on Red Hat. But it's never Red Hat certifying those guys. It's always those guys certifying themselves and saying, yeah, it works. Right? So it's up to them to know what does it mean, what's the best test suite. So for some key vendors, you have teams inside the company testing hardware, new boxes. Typically you try to make sure that Oracle works. The big ones, right? But the ecosystem is so wide that you can't take on the cost and weight of really doing that work for them. So it's typically the other way around that this happens. So what we see typically is cloud vendors go through a lot of certification. Even their employees need to go through the certification to make sure they're, pretty solid persons and so on. But I don't think this has really been tested in court fully. I also think this is a place where governments will have to step up. If you think about electricity, today it's highly regulated, right? A power plant can't just say, you know what, let's shut it down. Let's go, let's have holidays, right? And New York City is, no electricity? No, it can't work, right? It's a critical part of the economy. So they have a very big responsibility, and they have to follow extremely strict rules and so on. And I suspect in the 5-10 years, we're going to go through exactly the same regulation process for cloud providers, because if a cloud provider that has hundreds of thousands of customers shut down, the economy shut down in the same way as if electricity was shutting down. So I think we're going to go through more than just the contractual aspect, business to business doing a contract. I think the government will probably set some rules that need to be followed. So one last warning. Sometimes we hear, could I get a private pass? Because all of that looks pretty cool, right? Sure, we can also sell you a private jet. So again, the big value of a pass comes from the S. It's a service. And it's a standardized offering. And because it's standardized, it means it's not custom. And because it's not custom, it's easy to reach a critical mass because you can apply the same processes to a lot of companies. So it's cheaper. And it's better because it's done in the best possible way. So I think I see customization as a big risk in the cloud. If you want to customize and heavily customize, well, fine. But I think you're simply leaving the conditions that PaaS providers and IaaS providers can sustain, and I think you're responsible again. It's like if you were asking, can I get a 160-volt plug just for this toaster? I think it would be great. Yeah, why not? But I don't think that's going to scale as a business. So if we want to truly go through a commoditization of IT, we have to accept that it's a standardized offering that is provided as a service. Some companies might be big enough to accommodate that kind of critical mass, standardized, and so on. But I think the average company has a lot to lose by going there. So why am I telling you all of this? So I'm going to tell you a bit about CloudBees. Our mission is to help developers do Java, essentially, right? And to provide everything they need to do Java. And we're different, we think, because first you will see that a number of PaaS, as I said, you have lots of philosophies. Our philosophy is that doing application is not just about running application. It's not just about, an application, what do? Oh, I run it, done. Your job is actually to code that application, to build it, to test it. So there is a life cycle associated to that application. And we think that if the cloud is really going to help developers be more productive, it has to provide more than just a runtime environment. It has to help them through the complete application life cycle, and that's what we're doing. Then the other thing is, when I talked about philosophies and how much details you want to know about the platform, you're going to have providers which at one extreme provide all kind of details about the runtime. Azure would be a good example of that kind of environment. At the other extreme, you have providers that tend to hide that complexity and provide an abstraction. One of the first ones to do that was Google App Engine. So CloudBees is more in that generation of platform as a service, so we tend to abstract away things rather than expose those infrastructure details. So I'll speak about Dev at Cloud and Run at Cloud. That's two tag names I'm going to use quite a bit in those few slides. Dev at Cloud are a set of services during the development part of your job, and Run at Cloud, you can guess it, it's when you run or deploy your applications. So a few things about the team. As I said, we're about 30 persons. A bunch of us were born in open source. We've got people from JBoss, Red Hat, Steve Harris was Mr. Java at Oracle. We've got André Pinault, who was at Bluestone, at the back of the room. François was at JBoss as well. Kosuke Kawaguchi is the founder of a project that used to be called Hudson, now called Jenkins. Who knows Jenkins, by the way? Yeah, that's typically the type of answer I'm getting, more than who has used a PaaS. Jim was at Borland. Spike was part of the early founding team at WebSphere back in 2001. He was also part of the Alair team, Macromedia, and so on. So we've all been in middleware, and a bunch of us in open source for a few years. That's the exec slide. Actually, I realized I should show you the developer slide. That's a more interesting crowd for you, I guess. So we're founded 2 years ago. The headquarters are in Woburn, not too far from here. But as I said, the team is widely distributed. We have people in Australia, New Zealand, Ireland, France, Switzerland, the USA, and hopefully we're going to increase that list. We have some great customer references. That's also something I hope I can show you today, which is it's not just something you can use to play. It's not a toy. It's a real platform that has been in production for quite a bit of time, and we have some real customers. I'll speak about some of those guys and what they do. So why do we rock? Well, I think this is the best slide. So I made it small, that way you can't read, and that way you can't find all of the bugs I could have put on this slide. Essentially what you can see on that slide would be, what is the process you need to go through if you want to deploy an application? So the top are, the top boxes would be one-time activities, like I need to provision a cluster, which means I need to provision nodes. So it's install a database, configure it, secure it, set up the database, configure the operating system for the application server, secure it, set up the JVM. And so you have a bunch of things. And then you have some recurring activities. You need to analyze the logs, patch it, and so on. So it's pretty sophisticated. And what's worse is that actually most of those actions are high-friction actions between IT and developers. IT guys are the guys who want to sleep at night, right? They hate to be beeped at 2 a.m. because something broke. Their job is to make sure that it's rock solid. And developers, they like the newest funky frameworks. They want to try the new things. Oh, what's that? That's cool. So, not the same DNA. It's always great to push a new application to production. So what we try to do is really transform that high-friction process into something extremely easy, where the path will provide you with the abstraction you need, so you can take an application, push it, go, done. So I'm sorry I have to show you that slide, because typically when you have those slides, it looks like a bit marketing more than architecture. But I can tell you it's actually pretty good. So first, at the bottom, you're going to find the core services of the platform. Things like monitoring, management, logging, identity management, and so on. So those are really shared. That's our stuff. That's where we have billing as well. So they're kind of back-end services, if you will. You're not really going to see those most of the time. And then on top of this, you will see dev at cloud and run at cloud. So I've described that dev at cloud was more focused towards development time activities, while run at cloud is more geared towards runtime activities. So at the core of dev at cloud, we have Jenkins. So we reshaped Jenkins into Jenkins as a service. So Jenkins is a very, I asked who is using Jenkins, but I should have asked the other way around. Who doesn't know what is Jenkins or continuous integration? Yeah, OK. So Jenkins is an open source continuous integration server. So why do we need continuous integration, and what is that? So when you do software development, as soon as you have more than one developer, you tend to have communication issues. And what happens is, if you don't have a process to handle that, you're going to have one developer do some code on his laptop, the other one do some code as well. From time to time, they will commit the code in Subversion or Git, right? And they're going to do some tests, right? At least that's what they're going to tell you at the cafeteria, typically on their laptop. And it always works, and that's great. And at some point, somebody will take a fresh machine, do a complete checkout, test the application, and everything is broken. And what's great is that it's never going to be anybody's fault, because we're all great developers, right? So to avoid that, the only option is really to do heavy testing each time something happens. So a continuous integration server is like an independent machine, like the Switzerland of your build environment. And each time a new code is going to be contributed to your server, it's going to detect that, take a fresh copy of that environment, build it, test it in a clean environment, and if something goes wrong, raise a signal and say, John, it was working before. Now you did some check, and it doesn't work. Don't you think we should talk? Well, it's going to be less polite than this, but it's going to know very precisely who broke the build. And so you can react extremely quickly. And if it works, that's great. It's a last known good configuration, right? And we can move ahead. So it's a very important piece of technology. The problem with this is that IT guys in most companies won't care about Jenkins. They'll tell you, you know what? That's a developer thing. I don't want to deal with it, so do it. Okay, so you have a developer step up and say, okay, I'm going to do it. And you will be responsible for Jenkins. And the problem with Jenkins is that it's extremely easy to set up. And that's a problem because you get used to it. And then the good thing with tests is that you keep adding more tests. You never remove tests, right? Or you're not supposed to remove tests, except if they're showing a bug that is very hard to fix, right? Sometimes it's easier to just remove the test. And then when you do a branch of versions, well, you duplicate all of your tests because you have version 1, version 2, so you need to duplicate tests. So you need more machines, you add more slaves, and the guy who is responsible for that, end up managing this, right? So what we did here was we said, well, let's SaaSify Jenkins. Let's make it a SaaS. So we take it, we manage it, we make sure it's always up to date, that the plugins are working and so on. And we also want to make sure that you're going to have enough build capacity at all time. During the weekend, I'm not sure you're going to build much. I hope not. So you'll see that your Jenkins will not have any resources allocated. And then when you start adding some jobs, build jobs, we're going to dynamically inject some build machines to your Jenkins so that jobs are compiled as soon as possible. And then when the jobs are over, we disconnect those machines, sanitize them, and you're done, you stop paying for them. So it's really a great usage of cloud resources, right? Spiky usage, we allocate, we deallocate, perfect use case from the cloud. So Jenkins is a core element of Dev at Cloud. Then we also provide some code repositories, Git, Subversion, Maven, and so you can, all of that is nicely integrated together. You don't need to handle keys and so on. All of that is done for you. And then this is called continuous integration because you continuously integrate your code to make sure it's stable and working at all time. With SaaS in the cloud, this totally changes. If you have a business online, what you want to do is measure in real time how people are using your software. Let's say you're Amazon. You want to check how much time people stay on your platform. How long do they click? Do they go through the process of buying? Going through the bidding stage. Is it 30 seconds or is it 15 minutes? If it's 15 minutes, you have a problem. If it's 15 seconds, that's great. You have the impulsive buyers. So all of the SaaS typically have tools to measure in real time what's going on the platform. How do people behave on the platform? And so what they do is they're going to do micro updates to your application, to their application, to their service. So maybe one time a day or maybe more. They're going to do a micro change, push it to production, deploy it, measure. Is it improving the situation or not? If it's not improving, I roll back, I go back to the previous version, and I'm done, right? So it's that kind of behavior that we're getting to with the cloud. Extreme iteration of your software. So that's important for a PaaS to support. But then it's all great, but we're never going to be the best at everything, right? We know how to do that, I guess, pretty well. But then are we going to be the best to provide a NoSQL database or a New Relic for monitoring and sophisticated UI? No, we're not. So it's important for PaaS providers to provide an ecosystem where you have some services provided by third-party companies that can extend the feature set that the PaaS vendor doesn't provide. And so that's a bit like operating system back in the days, which is if you wanted to succeed as a company selling an operating system, if you didn't have an ecosystem, why people would buy your stuff, right? I'm buying an operating system, and the only thing I can do is open a compiler and write my own stuff. No, I want a database, I want an ERP, I want things to run on top. So ISV ecosystems are really what made or killed operating system vendors. Look at who is on that market. You have Red Hat, huge ecosystem, Microsoft, huge ecosystem, Novell, not doing great these days, but huge ecosystem as well. And there were the successful operating system vendors. So it's the same in the PaaS era, in the cloud era, you have the next generation ISV, which are SaaS providers aggregating around PaaS vendors. So what happens to other vendors like BPMs and so on? Well, first, great question. They probably wonder about the same. Integration will remain an issue. Workflow management will remain an issue. You see, each time there is a big paradigm shift, you can see new vendors emerge that have simpler way to solve the same type of problems, but more adapted to the cloud. Like you have, for integration, you have the good old ESB and SOA and so on, and you have new vendors like Boomi, for example, doing it very much adapted to the cloud with connectors not for CSV file or whatever, but connectors for Salesforce or Zendesk and so on. So, but to answer your question, we're going to see those companies morph into SaaS PaaS providers. And they're probably going to all come with their own platform. And for some of those companies, it's going to make much more sense to provide this as part of a PaaS rather than individually, because they're not going to be the center of the world anymore, right? It depends on what they're going to sell, but it depends whether companies will see applications as the center of what matters or integration as the center of what matters. So, but you will see those companies emerge with SaaS offering and hook to those PaaS providers. It happens for some of them. Some of them are late to market. Remember that each time there is a paradigm shift, it's hard for existing vendors to do that conversion because they have billions in revenue that are sold through existing channels. They sell one philosophy of doing things, and when they have to switch, it's a transition that takes time and is pretty sensitive to achieve. So it's not like they can say, okay, that's great. Cloud is cool, let's go there, right? So they typically have a dual language. You can hear them say, so cloud is great, but why don't you do it this way, which is a great way for them to to go there smoothly, I would say, from a revenue standpoint. And then there is no standard for integration of SaaS to PaaS. So, like the ecosystem we have, you have other PaaS with an ecosystem as well. And today you do not have a standard on how you integrate your SaaS with all PaaS. And I think that would be something that makes a lot of sense for the PaaS vendors, the Cloud Foundry, the OpenShift, the Heroku, the CloudBees, to all come up, standardize those API so that it accelerates the market and makes it easier for SaaS to integrate with all PaaS vendors. So this nice life cycle is how it's going to look like on the website. So I'm going to show you that after, but you recognize the repositories, the Jenkins build, the application, databases, and all other services. So a typical use case that we're going to show is this one. So you have an application, a project. You're going to make a Git push to your source control. This source control is going to send a notification to Jenkins. Jenkins is going to build it, test it, and deploy it to production. So that's a typical use case. Obviously, it's a la carte, important things. If you're using CloudBees, for example, you're not forced to use our Git because it's better, or our Jenkins. If you use your Jenkins, plus GitHub, plus whatever, you can do that as well. We have customers using just Dev at Cloud, for example. So storing code, building on Jenkins at CloudBees, and then deploying in-house or at another PaaS provider. And we have also people just using the PaaS at CloudBees and doing their own development their own way. So it's really a la carte. You choose. So key elements, complete application lifecycle, so dev and run. We're focused on Java. That's important. We think there is value in having depth in supporting Java and not just supporting anything. We abstract away developers from the infrastructure. That's something important to us. And it's available in GA, so we have people in production today. So one of the examples is Lose It. You might have heard about Lose It. It's a mobile phone application, so you can track what you eat and how much weight you're losing. I should personally install it. They have more than 10 million customers. They do up to 20 or 25,000 transactions per minute at peak time, so it's a pretty it's a pretty used application. And yet they have only 4 employees. And I used to say they have 4 developers. I talked to them today and they said, no, actually we have 4 employees, but only 2 developers. So why is it useful to those guys? Because they wake up in the morning and they just care about building the best application. Right? They don't have servers. They don't care about operating system. Is it this JVM or that JVM? They just look at their own code and try to make the best application. That's it. And I suspect the other guys are in marketing, promoting, doing advertisement, and the like, but they just focus on value. Where do they have value? Is it in walking around with RG45 cable, or is it in just doing their apps? And this kind of productivity is simply unmatched. 5 years ago, 10 years ago, being able to get that type of load with that few resources, with that few developers, you just can't do it, right? So to me, this kind of example doesn't say that, wow, it's impressive, only them could do it. No, everybody can do it, just because they focus on what they do well, which is code. And so when I hear people tell me, yeah, but you know what? I don't think my company is going to go in the cloud because, we have servers and we can do it better. And yeah, maybe. But when guys like this will enter into your market and start competing against your company, I can tell you you're going to see things slightly differently, or your boss is going to see things slightly differently, right? It's going to be the guy coming and say, so they release something, and they tend to release pretty fast, and it's pretty cheap, and they have tons of new features, but they're like 10. Why? Well, just because they focus on value, right? They don't try to maintain a huge farm of staff and monitor it and so on. So I think the market is going to be self-defining. Either you're competitive or you're not, and I think it's how the cloud would just expand. So by 2020, and I like by 2020 because it looks cool first, and 2, it's far enough so that it's not like it's tomorrow. Let's not stress out. It's going to happen slowly, but it's going to get there. And I don't know what will happen between now and 2020, right? But I know that at some point, and maybe it's 2025 or 2018, I don't know. But at some point, 10-year-ish, things will be vastly different. It will be either about SaaS, right? And the question will be, okay, I have a problem, a business problem to fix. Is there a pre-built solution on the market that fits my need? Can I find the Salesforce.com of my problem? If I do, okay, I'm going to use it. Done. If I do not find it, I'm going to use a PaaS because I need to build it. So SaaS or PaaS? Does it exist or do I need to build it? So that's going to be the 2 ways we're going to be working down the road. That's my guess. Operating systems now. Let's speak about operating systems. We've seen in the last 20 years a huge expansion of what operating systems do, right? From DOS to Windows 7. Let's say Windows Vista because it was even funnier in terms of weight. But we've seen operating system do pretty much nothing to operating system be those huge beasts, right? So what happens by 2020? I think we're going to see operating system as we know them today disappear. Just because as a server side, I don't care. Let's say you're using Salesforce and CloudBees. Do you care if Salesforce is using Windows or Linux or BSD or Sun? No, you care that it works. And as a PaaS provider, am I going to choose Windows or Linux? Am I going to spend 4 cents more an hour to get Windows because it's cool? Or will I use Linux? And you know what? I'm not even going to use Linux. I'm going to use what we call JEOS, just enough operating system. So we take a Linux typically or a BSD or whatever, you strip it down to just the bare minimum, right? Because I don't need all of those sophisticated features. I need to coordinate processes, I need to run firewalls, I need to store files, basic stuff. But I don't need, I'm not going to put a UI on top of that operating system. I'm not going to do all of that. I'm not going to have a compiler, those things. So it's very small, very highly tuned operating systems that I care about. And even on the client side, to be candid with you, I think we're going to see over time, today, I still think that native OS are kind of cool, but down the road with HTML5 and the kind of processing we can see, I think the operating systems we will need on the client side will be hugely different as well. Much more basic, right? We see Google with Chrome OS. If you tried it, it's pretty slick. And to me, at least for most of what I do during the day, it will be enough. So my bet is OS won't matter to IT customers anymore. It will obviously matter to PaaS providers, to SaaS providers, but to IT consumers, I don't think it's going to matter anymore. Middleware. Should I care about middleware? Well, first, it's a funny name, middleware. Have you ever thought about where it comes from? So it's really the where of the middle, right? So back in the days when we're all young and slim, you would, as a developer, directly code on top of an operating system. And then some smart guy said, well, you know what? You're kind of developing always the same thing, right? Plus, it's hard stuff like transactions, security, clustering. Can't we just factor that in some kind of layer, right, that we would reuse? And we would put them like in the middle, right, just between the operating system and your app. Well, was born the middleware. That's great. And by the way, I was making fun of my Red Hat guys when I joined Red Hat because they didn't quite get the middleware thing, right? So I was saying, but it's easy. You know, you have the middleware and you have the underwear. So they really enjoyed it. So that's great, and that was very useful. But now the question is, does it still apply in the cloud? Well, the notion of middleware as we know it today, as a static set of API that are well-defined, that are running in the same machine as your container, that's not how it works in the cloud. In the cloud, you tend to have a minimalistic set of services, and all of the resources, all of the services tend to be provided by third-party services. They tend to be remote. They tend to be accessed by REST API, for example. So yes, middleware remains in terms of what benefits it provides. Yes, you still need transaction, cloud or not. You know, you'd better have your bank account managed by transaction, right? You still need security. You still need clustering. But all of that is absorbed and managed in an extremely different way as part of a PaaS than it is today as part of application servers, for example. So the way we're going to see middleware is going to radically change over time. And even infrastructure as a service. Infrastructure as a service was just born, right? It's a new child. It's cool and hip and so on. But do you really care about it? Well, today you do, because you probably have some systems you want to use in the cloud that you want to migrate. And they need their own operating system, their own drivers, their own sophistication. So IaaS is a perfect way to do that. But tomorrow, they'll make no sense. Remember, your question is going to be, to my problem, can I find a solution? If I do, it's a SaaS. If I can't, it's a PaaS. But you'll never go and try to boot a machine and provision it and guess what happens when it goes wrong. So IaaS will be important to PaaS providers, to SaaS providers, but they're not going to be important to consumers of IT. You'll never address this layer down the road. It doesn't mean you won't care about IaaS vendors, right? You will care. You will ask us. You'll tell us, but your stuff, where is it running? Is it US East? Is it California? You know, if Amazon dies, you know, I want to watch CNN and say, oh, Amazon data center is down. Oh, my stuff has a problem potentially, right? That you want to know. But you're not going to work directly with IaaS providers as a construct, as a technical element. So I would welcome you to join the light side of the force. You can join CloudBees and try it. Why? Well, just because I think it's very hard to explain what is a platform as a service. I did my best in the last too much time, but it's never going to be something you can understand intellectually. You need to experience it, you need to toy with it, you need to see how it works, how it compares with what you're doing, because your job on a daily basis has lots of implicits. You do a lot of things because you're used to do those things in a specific order. Will you get the same thing on a PaaS? Well, try it. My bet is that once you try it, you'll get pretty hooked to it. But I think that's something you need to try. You can try any path. I would actually encourage you to try multiple paths and make your own religion about what you think is the best path. But put CloudBees as part of your top 3. OK, so if you don't have any other question, thanks a lot for coming to this presentation.